thank you all again for being here. I hope not to be not too boring. And yes, today I will talk about synergistic approach, things that are very, very novel and need to be developed. So I hope to plant the seeds of novelty so that you can help us develop these approaches. In this first slide, you see me performing the transcranial sonography on myself, performing transcranial sonography on somebody else, and you see this gentleman over here, who is, his name is Francoforte, and even though he may sound a German name or an Austrian name, he was an Italian who lived in Trieste, that was part of the Austrian Empire at the beginning of the 20th century. This guy had characterized the different neuronal layers of the human brain, of the cortex, those that Dr. Bradstreet showed yesterday, demonstrating that, for example, in autism, there is a derangement in those neuronal layers. Today, I will be talking about myalgic encephalomyelitis and autism, and I will refer to this seminal paper which demonstrates or shows the international consensus criteria for this disease. By the way, today we are honored to have in this room two of the authors of this seminal paper, and I must add that another author of this paper lives and works in Australia, is now using food-based Gcmaf for about 1 year with good results. And I just recently learned that also Professor Montagnier, the Nobel laureate for his discovery of the HIV virus, now is interested or works with ME or CFS. I hope you will forgive me if I call it CFS, which is an old name, but it's difficult for me to pronounce myalgic encephalomyelitis. So, as we see, retroviruses, they merge with each other. Retroviruses, I think, another person in this room agrees with me, that are extremely dangerous. Whether they do exist or they don't, they're extremely dangerous for scientists who work with them. So I think we agree on this point. Professor Montagnier also has experienced the danger of retroviruses. But I will not talk about retroviruses today, and later on we have the honor to have Professor Demerlier, who will talk about most recent developments in the etiology and pathogenesis of encephalomyelitis. When I prepared this slide, I didn't know the results of Professor Demerlier, and therefore I wrote that the etiology, which is the cause, is unknown. Is it multifactorial? Well, we'll discover later on in half an hour or so. What we know is that it is characterized by widespread inflammation and neuropathology. I think we may all agree on these terms, and that is a neurological disease. And this is the way it is characterized by the World Health Organization. And I think you all know that the major symptoms of CFS are neurological impairments, neurocognitive impairments, difficulty in processing information. All this comes from that paper. Short-term memory loss, neurosensory perceptual motor disturbances, and inability to focus vision, and so on. By the way, many of these symptoms are common to autism, so it is likely that these two pathologies, they have something in common. And one of the pathological findings underlying these symptoms in CFS is the reduction of the volume of the gray matter in the brain. So this is a paper that was published by radiologists, neuroradiologists, in this journal called Neuroimage, demonstrating that people suffering from CFS have a reduction of approximately 8% of their gray matter. Gray matter, we all know, are neurons. And if you have less neurons, you can expect some problems, because neurons are there to perform their work. So they demonstrated very brilliantly with this magnetic resonance imaging, sophisticated one, that there is actually a reduction that they could measure. We have been working for the past several years together with our co-work colleagues at the University of Florence on heavy metal environmental pollution, and in particular with cadmium pollution. I remember that yesterday heavy metals had been mentioned more than once during the talks concerning autism. And probably they have to be mentioned also when dealing with chronic fatigue syndrome. We know that cadmium, for example, which is one of the heavy metals that unfortunately pollutes our environment, is widespread, and it induces neuronal death in cortical neurons through a combined mechanism of inducing apoptosis, which in itself apoptosis is not a pathologic process, but when it is excessive, of course, it becomes, and also it induces necrosis of the cells, which is a pathologic process in itself. And it is now well assessed that the cell death, whether through apoptosis or necrosis, induced by cadmium, is responsible for the effects of cadmium at the central nervous system level. And these are a decrease in attention level and memory, and a diminished ability for training and learning in rats. And these symptoms, as we all know, or at least as people who are familiar with CFS know, are pathognomonic, that is, they characterize the syndrome, the CFS. This is a paper that was published by my colleagues. They didn't put my name on this paper because I didn't do anything. So they did well. So they published this paper in 2012, so quite recent, in this journal called Biometals, demonstrated that cadmium induces alteration in the human spinal cord morphogenesis. So here we're talking about human specimens, and the cell density here in the ventral horns was significantly reduced. And of course the white matter that here is stained in pink is increased because it has to fill the space. Now you may wonder, what has all this to do with Gcmaf? And it has to do with Gcmaf, at least at the potential level, because it might explain some of the effects that have already been observed with Gcmaf in treating autism, in treating CFS, and why not in the future in counteracting the effects of pollution, environmental pollution. Why? Because Gcmaf, we already know, and I will show you some results obtained in vitro, counteracts the effects of heavy metals on cell viability and metabolism. We already know that Gcmaf stimulates adult neurogenesis and can restore the gray matter reduction that is observed in chronic fatigue syndrome, for example, and of course it is observed in other neurodegenerative diseases such as Alzheimer's. Actually, that's the primary disease where you observe a decrease of gray matter. And also, we have already learned yesterday that Gcmaf reduces systemic and local inflammation that plays a part in the progression of chronic diseases, and of course plays a part in the progression of chronic fatigue syndrome. If you go to the National Library of Medicine of the National Institute of Health of the United States, and you just search for heavy metal and neuronal cell death, you find more than 500 papers demonstrating this. So this is a well-assessed effect. And here, last year, in the nice island of Sardinia in Italy, there was the International Symposium on Cadmium, and my colleagues, again without me, but it's okay, they presented these results. Actually, Gabriele yesterday, Dr. Morucci, showed you how we can easily measure cell viability by measuring the mitochondrial activity of cells. So these three columns represent normal cells, that is cells treated only with vehicle, control cells. These are the same cells treated with the same concentration of cadmium that you can expect to find during environmental pollution. And these are the same cells that have been concomitantly treated with cadmium and Gcmaf. So you see Gcmaf somehow restores the ability of the cells to survive, restores their energy level, which is something perfectly consistent with what we have observed in several cell types, and it is also consistent with what we see with the results in vivo. Now, let's talk a little bit about adult neurogenesis. Most of us were taught in our younger years that neurons do not proliferate, do not grow in the adults. And unfortunately, as of today, when I ask students, can you please name a list of those tissues that in the adult do not replicate, do not regenerate? Unfortunately, they still raise their hands and say, neurons do not regenerate. That's wrong. It is now about 20 years that there is an exponential growth of papers demonstrated that in adults, as we are, the neurons, they are dividing in this precise moment. If neurons were not dividing in the subgranular area, the CA1 area of the hippocampus, we would not be able to learn anything, to memorize anything. We could not even think at ourselves. So neurons, they do divide in adults, and yesterday, Dr. Morucci showed you that Gcmaf is able to induce neuronal proliferation in vitro. So we don't know as yet whether this is reflected in vivo, but at least in vitro, looking at human neurons, if you stimulate them with increasing concentration of Gcmaf, of course always compared to the control, which is the inert Gc protein, you see neuron proliferation and differentiation. So this might explain some of the effects of Gcmaf that yesterday have been reported concerning, for example, depression, and some of the effects that have been scantily reported about the effects of Gcmaf in other neurodegenerative diseases. There are no statistics, these are anecdotes, nothing more than anecdotes, but at least we have the in vitro explanation why Gcmaf could have some neurological effects, why Gcmaf is so effective in autism, in addition to its function in modulating the immune system. So I think it's a new information that Gcmaf acts directly on human neurons and can promote adult human neuron regeneration. And then we go to something that is more familiar for us, that is the role of Gcmaf in systemic and local inflammation. I already presented you yesterday these two papers of ours that we published in 2012 that highlighted the role of inflammation, and this one also the role of nutrition in the progression of diseases from chronic fatigue syndrome to cancer in the last stages that are called anorexia, cachexia. Talking about inflammation, I'm not presenting you any clinical case because I only know about clinical cases shown me by other doctors who treat patients with Gcmaf. This is one subject who was assuming Gcmaf in the form of the food-based Gcmaf, and among other things, he observed a decrease of neutrophils from 77% to 55% in about 10 weeks, and this indicates, in our opinion, a normalization of hematological parameters that were suggestive of a pro-inflammatory state that is common in all chronic diseases, from cancer to other chronic diseases. And these results were paralleled by the increase in the albumin globulin ratio from 117 to 166, and a decrease in the C3 and C4 complement concentrations, respectively from 120 to 86, from 33 to 19. So it is a consistent picture of decrease of systemic inflammation that you observe when people are under Gcmaf treatment, whether injected, whether assumed as a food-based compound. Many times, many doctors, they don't look at these parameters because, of course, they are concentrated on the parameters or the markers that are specific for the disease that they are treating, like PSA if you are treating prostate cancer, or other parameters if you are treating other diseases. Since we don't treat anybody, but we simply revise the clinical records of other doctors, we take our time also to look at other parameters that are not directly related to the main disease, and we discover these things. That, for example, during Gcmaf treatment, there is a decrease of those indexes of systemic inflammation that, of course, are irrelevant for a stage 4 cancer patient. A stage 4 cancer patient wants to look at the reduction of the mass, reduction of the metastasis, or reduction of the tumor markers, but we also take a look at these, and they give a comprehensive and consistent picture. Now, we can now look at the local brain inflammation, which plays a part in myalgic encephalomyelitis. Well, the name encephalomyelitis, the itis stands for inflammation. Probably is not inflammation only of the white matter, probably it's a diffuse inflammation that we can now monitor with an easy, cheap, simple and comfortable method that is in the back of the room, the transcranial sonography, that we did not invent, but we are just out of serendipity perfected so that it can be used easily.